In the previous video, we looked at the functioning of the diode in these two conditions, right? We looked at the diode functioning when the voltage across the diode is greater than zero. And next, we looked at when the voltage of the diode is less than zero. And we said there is a current that flows through the diode here, but there will be no current that would flow here. Now, that was not entirely accurate. It was not inaccurate, but we'll just see uh, a more precise way of expressing the relationship here. So, one way to figure out how components work is to look at mathematical models of how these components function, right? So for example, in an op amp, we said, well, let's make a model of the op amp, and we built the ideal op amp model where the output was equal to the differential gain times the differential voltage. And similarly, let's build a model for the diode, for the ideal diode, and then we'll look at some deviations from that. Okay, so here's how an ideal diode would work. So if the voltage is greater than zero, as we are showing here, then the diode can basically be replaced by, so let's say, so it can basically be replaced by a short. Okay, so you have this voltage here which is greater than zero, so the diode can be replaced by just a wire. It allows for current to flow through this. Okay, and the current that is flowing has to flow in this direction. I uh, is greater than zero, let's call it. Okay, now if the voltage across the diode is less than zero, as is in this case, V is less than zero, then the diode model is basically an open circuit. Okay, it's not connected, and therefore the current has to be equal to zero. Does that make sense? So there are two parts of the diode. One where the voltage across the diode is positive, and in that case, the diode just allows whatever current needs to flow because of the circuit to flow through the diode, and the current is greater than zero. But if the voltage is negative, then it just acts as an open circuit. It does not allow any current to flow through. So this part of the diode characteristic where you have a current passing through is called the forward bias of the diode. Okay, while the other one is called the reverse bias. Okay, in one way you can think of it like this, that the voltage applied allows the current to flow in a forward direction, but here the voltage is applied in a reverse direction because V is less than zero, and therefore no current flows through it.